So let's talk about section 6.3, finding probability using a normal distribution. Now we've already calculated probabilities using a standard normal distribution, but now we're going to go with just a regular normal distribution. Recall one of the key properties of a normal curve is that the area under the curve for any region is actually equivalent to the probability of a random variable that falls within that region. In previous sections, we did it with the standard curve using our z's, but what happens when you're finding areas under just a regular normal curve? Now, we can find the area under any normal curve, and therefore the probabilities are normally distributed variables by first converting x's to standard scores and then using that standard normal curve. Okay? So recall that there are four basic types of problems that we have with our probability. We have probability that some random variable will be less than some value, the probability that some random variable will be greater than some value, the problem that some random variable will be between two values, and then we have the probability that some random variable will be less than one value or greater than another value. Understand that with each of these four types of probabilities, 1, 2, and 3 are done very easily using the calculator. Number 4 can still be using the calculator, but it does help if we use the complement rule instead. If you're using a z-table, number 1 is going to be the easiest with the z-tables. 2, 3, and 4 will require a bit more work if you're using a z-table. So let's start with our first problem. The body temperature of adults are normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.73 degrees Fahrenheit. What is the probability that a healthy adult having a body temperature less than 96.9 degrees Fahrenheit? Again, look for your keywords there. So some of the keywords that I'm beginning to see is that it's asking for what is the probability. They also said that some body temperature is less than 96.9 degrees Fahrenheit. Right there, that's what we kind of want to translate into a bit more of a mathematical notation versus just also wordy. So we're really interested in finding that probability that that person's body temperature, which we'll say is our random variable x, is less than, remember the less than symbol there, is 96.9 degrees Fahrenheit. Now, for us to see that written mathematically, that's going to be p parentheses x is less than 96.9, close the parentheses. Now, it also helps to kind of draw this out, but remember, if you're using a z-table, you're going to have to convert that x value to a z first. So we are going to need to do that as well. So remember, to convert to an x to a z, you're going to use that z equals x minus mu, all divided by the standard deviation. So I'm going to take that 96.9 minus 98.6 and divide that all by 0.73, which is approximately equal to a negative 2.33. Now remember, we're rounding 2 decimal places because this is a z-score, and our standard rounding for z-scores is 2 decimal places. So if I were to look at this at the two curves, so I drew one that's a regular normal curve, and I drew the second one, which is our standard normal curve. Remember, a standard normal curve, that's the one with the z, and you'll notice I've put a little z there, okay? That is the one that's going to have, as you can see, 0 as the mean. And then because my z value is negative, we know it should be slightly to the left, which is our negative 2.33. For my regular normal curve, you'll see I've notated it with an x here. 98.6 was our mean, so that should be in the middle. And then my x value was 96.9, which is right here. Okay, they should look very similar. And you'll notice I've shaded the area that is less than it, because that's the area that I'm looking for my probability, okay? And that's basically what we're looking for. So we basically need to find the area that's left to that negative 2.33, that z value, which also can be written mathematically as p of z is less than negative 2.33. And again, the picture on the right is if it was just a standard normal curve, whereas the one on the left was a regular normal curve. So we have kind of two options. We can either look up negative 2.33 on the cumulative normal table, or we can use the calculator to find that shaded region, and which will be approximately 0.0099. So if you're looking at the table, it's literally just by following the table. However, if you're looking at it with the calculator, remember how you're going to type it in the calculator. So remember, with your calculator, you're going to hit second bars, you're going to go to number 2, normal CDF, and then you're going to put in, now remember, it's everything to the left, so we have to go to a negative infinity. So -1, second comma, to get that EE 99, and then we're going to move to our upper bound, which is going to be that negative 2.33. And because we're in Z's, we're just going to keep that mean as 0, and my standard deviation is 1. Paste it in. Remember, those that have the TI-83s, you're just going to type in that lower bound, comma, upper bound, comma, mean, comma, standard deviation, close the parentheses, hit enter, and you'll get the same thing. Again, you'll notice it's very similar, almost exactly the same as what you had on the table. Okay. Now, this is, again, if you're using what we've previously done already. Now, there is one other alternative method. So let's talk about this alternative method. Now, this can only be done for those that have TI-83 or 84s or those Casio 9000 calculators, okay? So when using a TI-83 or 84 calculator to solve this problem, it's actually not necessary to convert to a standard score. The probability can be found in one step by entering that normal CDF, going from a negative infinity to our x value, which is 96.9. And then instead of saying comma 0, comma 1, because those would be z values, we can switch it to our x values mean, which was 98.6, and our x value standard deviation, which was 0.73. Okay, and you can see it here in that screenshot there. Again, whether you have a TI-83 or 84, you can do this as well. But again, remind yourself that if you're using the x's, make sure you use the mean and the standard deviation for the x's. If you're using z's, then you have to use 0 and 1 for your mean and standard deviation. But do remember, the only way you can use the tables is if you actually use the z-scores. So let's look at another problem. So the body temperature of adults are again normally distributed with a mean of 98.6 degrees Fahrenheit, and the standard deviation is 0.73 degrees Fahrenheit. What is the probability that a healthy adult having a body temperature greater than 97.6? Now again, there's that key word. It's body temperature greater than 97.6. Now the body temperature represents our x value here, and we're looking at a greater than symbol. Okay, so it's always helpful when looking at any word problem to always kind of translate it and take what we're actually interested in finding that probability that that body temperature x is greater than 97.6 degrees Fahrenheit, and write it mathematically. So we're going to say our probability P of x is greater than 97.6, which is literally just the words translated into kind of a mathematical shorthand. And then it also helps to draw a picture, okay? Again, if you've got anything lower than a TI-83 or 84 and you're going to try to make it through this class using the tables, you're going to want to make sure to convert to a z-score first. For those of y'all that don't want to learn a new method, you also want to make sure you get that z-score. So the z-score is going to be x minus mu divided by your standard deviation. So you got your 97.6 minus 98.6 all divided by 0.73, which is going to give us approximately a negative 1.37. Again, my curves, no matter which way I draw it, if I draw it using my x variable or if I draw it with my standard variable, my standard z, they're both going to look exactly the same. You're going to have your value and then shade everything greater than it. Now again, notice I'm shading everything straight to the right, no matter which one I'm looking at. So you can see what your lower bound is and you can see what your upper bound is. Okay, so that's the first thing we're going to do is we're going to find that area under the standard curve. Again, if you're going to switch to z's, make sure that you also rewrite your probability shorthand to show that it's using a z. So say the probability of z is greater than a negative 1.37. Which basically is the right of the graph. And please understand that when you're looking at your table, you cannot use the table straight out. You do actually have to take 1 minus what you get there, or you're going to have to find that the flip version of it, okay? So there's a little bit more work if you're using the cumulative normal tables. Those that are using a calculator, it's again, type in that lower bound, your upper bound, and then also your standard deviation of 0 and your mean of 0 and your standard deviation of 1, and you'll get that 91.47. Do understand that if you are going to use the x values, you can still do that as well. So again, if you're going to use the x values, remind yourself that it's not necessary to convert that 97.6. You're just going to start with that lower bound and then your upper bound and then your x values mean and your x values standard deviation. Okay? And so you'll see here, this is what you should be typing into your calculator. Again, those of y'all that have the TI-83s, remember it doesn't have that beautiful pop-up menu that tells you to type in the lower bound, comma, upper bound, comma, mean, comma, standard deviation. That's something that you're going to have to remember because that's not given to you with your calculator. Those of y'all that have the TI-84, it does give that to you. So that's kind of nice. With the upgrade of the calculator, it does give you that pop-up menu that answers everything. Okay, let's try another question. So the body temperature of adults are normally distributed. Again, 98.6 degrees Fahrenheit is my mean, and my standard deviation is 0.70 degrees Fahrenheit. What is the probability that a healthy adult having a body temperature between? Okay, everybody see the word between. Again, body temperature is my variable, so my variable is between these two things. And what we're going to do basically is rewrite that in a mathematical way. So since we're interested in finding the probability that our x is between 98 degrees Fahrenheit and 99 degrees Fahrenheit, written mathematically in shorthand notation, that's going to be P of 98 is less than x, which is less than 99. Again, notice how x is between these two numbers, and make sure that these are both going in the same direction on your symbols there, okay? And we're going to take a look at both of the graphs again. I'm going to do the standard score just for those that do not have a TI-83 or 84 calculator. But again, for those that do, you can kind of just look at the regular normal curve now. So if I am doing it into the z-scores, do understand that the 98 degrees Fahrenheit translated into a z-score is a negative 0.82. 99 translated into a z-score is 0.55, and you're going to have that graph that looks something like this over here on the right-hand side. On the left-hand side, this is going to be for those that do not need to convert, so those that have that TI-83 or 84 that don't actually have to convert it anymore, you have it here, okay? Again, the graph should look almost identical. And again, I highly recommend draw the graph each time just because it's very helpful. If you'll put the graph down, you can see what is your lower bound, okay? And you can see what is your upper bound. So we can see there that 98 and 99, there's my lower and there's my upper bound. We can also see that if I'm looking at my z's, it's a negative 0.82 and a 0.55. Okay, so now that we know that the area that we're calculating is between these two things, understand that if you are using the z-scores and you're using the table, you are going to have to find basically the area to the left of 0.55, and then that's going to come straight from your table, and then you're going to find the area to the left of a negative 0.82, and you're going to take the big minus a little, and that will find you your area. If you're using your TI-83 or 84 with z-scores, it would just be that enter your lower bound, comma, upper bound, and then make sure you're using a 0 and a 1. You'll notice that you'll get a 0.5027 as shown, okay? And then, again, you could still use it with the x's as well. So here we have our nice, lovely, this is what it's in the calculator, and you're going to get that 0.5027, okay? Again, if you are using the calculator and you're doing it with the x's, you're again going to get the exact same answer. There's no need to actually create the z's if you have a TI-83 or 84 calculator. And this would be what you would enter in. And you'll notice you'll get pretty much the exact same answer. Okay, so let's look at another one. So the body temperature of adults are normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.73 degrees Fahrenheit. What is the probability that a healthy adult having a body temperature less than 99.6 degrees or greater than 100.6 degrees? Okay. Again, so I'm noticing that I'm having less than some number or greater than some other number. That right there is going to tell me that we're interested in that probability that a person's body temperature, that's our variable x, is either less than something or greater than something. And to denote that mathematically, it's going to be P of x is less than 99.6, and then we're going to actually use the word or, and then say x again is greater than 100.6. So this is going to kind of take us back to when we were learning probability in the earlier chapter, okay? And you're going to see that as we look at the next slide on our pictures here, you are going to shade everything to the left of 99.6 and everything to the right of 100.6. And there should be kind of a gap in the middle here. Again, if I have my normal curve with my x's, I have the graph on the left. If I have my normal curve with the z values, that's going to be the one on the right. And again, either one is going to be fine. If you are using the z tables, remember I said this one's going to take a little bit more work because the z table only give you areas to the left, so you have the area to the left here, but you won't have the area on this side. So you'll have to find this and then add it to, and this part here is going to take a little bit more work. Whereas this one, it is going to take a little bit more work in the calculator as well, but not as much as it would on the normal z tables. Okay, so what we're going to do is we're basically going to calculate out what those areas are. And again, you can use the z's or the regular x's for the calculator. Okay. Now, once you do it, you are going to have to do this twice. So I'm going to do it once with finding all the area to the left of our first one and then all the area to the right of the other one. And then once we get them, we're just going to add them together. So if you are using the z's in the calculator, don't forget that you are using a negative infinity. So remember, you're going to say a -1 second comma to get the e in there, and then 99. Remember, what that's doing is that's typing in a really, really small number. If you are looking for a positive infinity, it's going to be 1 and then second comma 99. So just make sure that one is positive. If it's a positive infinity, it's negative if it's a negative infinity. Okay. Once you get those answers, you'll notice I've taken more than 4 decimal places. You don't want to round a little early. You want to actually take more decimals than you need before you add them together. Okay. So once you have them, then you want to add them together. Okay. Now, this is going to be a little bit more work, but remember, I said that this is if you're finding them separately. Now, if you're looking at the table, you're kind of doing something very similar. Now, if you think about it, let's go back to the graph real quick. And as I look at the graph here, I notice that basically when I'm taking a peek at it, I'm beginning to notice that this area in the middle is the only thing not shaded. So it makes a perfect candidate for finding what we call the complement. So if I find this area and then subtract this area from 1, because we know all area under the curve is 1, then I'm going to know all the other area that's colored in. So let's try that out. So in order to do that, remember that we're going to say 1 minus our normal CDF, and then our lower bound in this case is going to be 99.6, and our upper bound is going to be 100.6. I'm going to use my x value mean, which is 98.6, because I'm using 99.6 and 100.6, so I know I'm in my x's here. And my standard deviation for my x's, which is 0.73. And again, you can see that in the beautiful screenshot of the calculator here. But again, I know I'm doing this because I'm looking for the area between those two, okay? And you'll get that same answer, you'll notice, that we got earlier. But again, it's a little bit nicer because when you're looking at it this way here, you're looking at a normal curve and you're finding basically this is the area that the normal CDF is looking for. But when we say 1 minus, this is the area we're actually getting, okay, which is really kind of cool. All right, let's try another one. Body temperatures are again normally distributed. 98.6 degrees Fahrenheit is my mean. My standard deviation is 0.73. What is the probability that a healthy adult having a body temperature that differs from the population by more than 1 degree Fahrenheit? Okay, now I switched up my words a little bit. So I use the word differs from the population mean by more than 1 degrees Fahrenheit. Now what does that actually mean? So this is where those words are going to start to change up a little bit more because we are so used to seeing less than, greater than, between. So we need some little bit challenge, right? So because we want to take the difference that differs, differ kind of means to add or subtract, right? So we need to basically add and subtract 1 degrees Fahrenheit from the actual mean itself. So we're going to take that 98.6 degrees Fahrenheit, that's the mean, and we're going to subtract and add 1 to get those, okay? Now, in doing this, this is going to give us 97 degrees Fahrenheit and 99.6 degrees Fahrenheit. But remember, basically, it's saying that we are interested in finding the probability that a person's temperature is less than 97.6 degrees Fahrenheit or greater than, because remember I said it differs more than 1 degree, meaning in either direction. It differs above or below, okay? So to denote this, this is going to be very similar to the last one we did with the probability that x is less than 97.6 or x is greater than 99.6. And again, it's really helpful if you'll picture that in a graph. So if I have my graph here, the graph on the left is with my x's, the graph on the right is with my z's. Again, if you're using the z table, this is going to be the one you're looking at. If this is the one that you're going to be with your calculator, it can be this or this. You have a little bit of an option there. Okay. Again, taking a peek at this graph, noticing that, again, even with a table, we're really looking for what's to the left of 97.6 and what's to the right of 99.6. But realistically, when we're looking here, we are kind of looking at what's between these two items. So think about it. If we look at what's between these and subtract it from 1, it really does help us out, okay? Now we have also something really interesting that I notice here is that when I converted it to z's, it became very obvious that these z-scores are almost identical, except for one's positive and one's negative. So when 97.6 degrees switches to z of, it becomes a negative 1.37. And when 99.6 becomes a z value, it becomes 1.37. So what's really cool about that is basically they're equal distant z-scores. So realistically, if I just find one area and multiply it by 2, I'd actually get my answer, okay? So again, it's kind of your choice on how you want to find these. If you are using your nice, lovely table, you would just need to find the area on one side and off the table, which will give you 0.0853 and multiply it by 2. And then therefore your probability is going to be that. If you are going to be using the, you're getting a probability of 0.1706. If you are using a TI-83 or 84 calculator though, however, you probably don't want to make all this extra bit of multiplying it by 2. This is mainly for those that are using the tables to help themselves out. Those are my people that are trying to use a TI-30 through or 36 through the course. It becomes a bit more difficult in some of the sections because there's a lot of formulas they have to memorize, but there is a table that will help them out with the normal. But for those of us that invested in that better calculator of a TI-83 or 84, that was highly recommended for this course, all you have to say is 1 minus that normal CDF of 97.6, 99.6, comma, your x values mean and your x value standard deviation as shown in the next screenshot. And again, you'll get pretty much the same answer of 0.1707. And it's actually a little bit more accurate than the other one, than using the tables, because the tables are pre-rounded.